My name is Claire, and we're on the second Python notebook for our SPICE program. So in this notebook, we're covering conditionals and loops. And so the thing we need to know before we get started on talking about conditionals is the concept of booleans. So what a boolean is anything that results in either true or false, specifically with a capital T and a capital F. And these are kind of like the foundations of all computer logic. It's with these operations that evaluate to either true or false as an outcome. And so here is a kind of nice lookup table just to show you the different operations that you can do. And so here we have an equals equals, and so we're saying if one number or one variable is equal to another. It's really important to make sure there's no confusion that equals equals is for specifically comparisons when we're doing these Boolean operations, whereas a single equals is for an assignment, so like for a variable assignment. If you mix these two up, you might overwrite your variables with a different number or other data. And so we have the exclamation point, which stands for not. So not equals, so you want to say that two variables are not equal to each other. And then here's some that you might have learned in your math classes, which is just greater than, less than, greater and equal to, less than or equal to. And so we can use these mathematic operations to have true or false outcomes. And so take a moment and just try writing some equations testing these different symbols so that you get used to them. For now, we have our 10 is greater than 5, and so this will result as true since 10 is greater than 5. This is taking a while, but someday it will resolve. So Boolean operators use Boolean logic, and so we can write an expression out using and or not. And so if we want a Boolean operation to only come out as true based off of multiple conditions, then we can use and or not. And you can do more than just like two comparisons. You can theoretically just kind of go indefinitely. So if you wanted these two and you wanted to add another one, you can just say and then another expression, etc. And so this is good if you want to have multiple conditions that you want to have your expression go through. And so take a moment and test these Boolean operators on writing your own expressions that have an and or a not. This gives us a segue to conditionals. And so conditionals are based off these Boolean results. And so the syntax of a conditional is what's known as an if statement. And so if statements are simply just the if, and then they can be followed by an elif, which stands for else if you have another if conditional, and then resolve in an else. And so we can see an example here where you have a if, and we have our variable condition, and then we have an else. What's really important to note is that in Python, the syntax cares a lot about these indentations, so these white spaces. So usually it's written out as you have your if condition and then you tab for the space, and then you write your command. If, for example, we do not have the correct indentation, it will actually throw a indentation error. And so here we have the indentation error. It's expecting an indented block, and it actually tells you which line that it is encountering this incorrection. So now that we fixed this, now we have our statement. So how conditionals can work is that this if statement needs to evaluate some form of a condition, and that condition needs to have an outcome of either true or false. And so here we just have, we just made condition itself a Boolean and having it result in false, but we can have actually an expression instead if we wanted to have assign like condition is actually a number, and then we actually have our condition here to say if it is greater than 2. So now this will have a Boolean outcome of 2 in this conditional, not 2, but true in this conditional statement. So this will now evaluate as true. We can say if it is less than 2, which will then proceed as false, since 10 is larger than 2. So you can get a idea on kind of having code that runs for only specific instances and maybe running differently or not running for other instances. Here we here's an example based off information that we learned in the previous notebook. So we can define a variable, and our condition, for example, is using that modulo. And so modulo calculates remainders. Oh no, I have a syntax error. Because I need to say num mod 2. And so then this will run. See, this number is even because the remainder of num mod 2 is 0. It divides by 2 evenly, as all even numbers do, so then this number is even. So maybe take some time on writing your own if statements with your own conditionals and see what you can calculate. One thing to be aware of is that you can have multiple conditionals by having elifs, and so you would just be writing the word elif and then your condition. We can have if num equals num, and print, oh no, see, my indentation is incorrect because I didn't put what I want like the actual action to be. And so you can have like an unlimited amount of elif statements. And you can just have as many if statements that you need. So it can be if and elif elif, 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 and else. The only thing that is required is for just like the first if statement. Everything else is optional. So now that we've talked about conditionals, we can move on to loops. And so loops are great for when you want to perform an operation multiple times, and Python is able to do several types of loops, and we'll cover a couple of them. And so the most basic type of loop is a for loop. And so a for loop iterates over any object that is sorted. So a list or range or string, and we'll get into examples for each of those. The basic syntax is for element in the object, and then you have an action for whatever that operation is that you want to keep repeating. So this goes back to our previous conversation about strings and how strings are read in by the computer. And so we start with the for, and we can have this variable character to represent the individual characters of this string hello. Technically, you can name this variable whatever you want. You can name it x, you can name it var, but we want to have an informative character. We want to have an informative variable so we understand what we are trying to do when we're looping through this string hello. And so what this will do when I run it is that we're printing character while running through each indice of the string hello. Oops. And so what it will do is that we'll print each individual character. So we're printing HELLO, as we can see from this print. We can combine it with the conditionals that we just talked about, so we can have an if statement actually in the for loop. So this will only print when the character is equal L. So here we have our L's. So you can kind of get an idea on having these operations where you're kind of performing the same operation, but only on if specific conditions evaluate. So in this case, we're only evaluating this operation within the for loop if we see else. And so you might be saying, Claire, we are always working with strings, but I want to work with actual data. And so that brings us to lists. So lists and strings behave in very much the same way. That's why a lot of tutorials will begin with strings before you move on to other more interesting data types. And so a list is actually what is known as a data structure because it is a way for Python to literally structure your data. We'll go over other data structures in a different notebook, but the most basic and intuitive are lists. So lists basically just contain different points of data. And so, for example, we can have a list called fruits, and just like your variables, you do not need to predefine that this is a list. Python will assume it as long as you have the correct syntax, which is just an open square bracket with your objects separated by commas and then the closed square bracket. And so these lists are always sorted, and you can perform different operations. here are a list of really common methods that you would use with lists. Try to take your time on trying out these methods, and you can try them out here. And so lists are a good way of keeping track of your data, or iterating through each data point that you have. And so in this example, we're using a for loop instead of the strings as previous to our list of fruits. And so here we're just printing out each type of fruit, but you can do different operations that you can try out, like maybe counting how many fruits that you have. So here we have a counter for counting each fruit. And so if we actually print the counter, then we have we'll have our 3 fruits. You can think about that if you're going through data that you might want to calculate how many occurrences that you have of something. So you can do it in this kind of way. You can account for different types by having a conditional. So back to our if statements, for example, maybe we only want if the fruit type is apples. So here we're only counting our occurrences of apples, which will only be 1, because in this list we only have 1 apples. Of course, we can add more apples to have it evaluate to a different counter. So what's important is that we're initializing our counter outside of the for loop, because if we didn't, it would get overwritten each time of the for loop. So for variables that we want to keep track of as it proceeds through the operations of a loop, we need to have them outside of the actual for loop statement. So for example, in this current setup, we are keeping track of the number of fruits, right? So we'll return this back to what it was before, in which we have the counter and it's counting the number of fruits, and we'll have 3 fruits. But if we didn't initialize the counter outside of the for loop, and we, for example, put it inside, it will keep overwriting itself. It's not saving the data as it goes through the next step of the for loop. So it's important to think about what data that you want to save or keep track of when you're going through a loop versus data that you don't necessarily care about. So sometimes when you go through a for loop, you don't necessarily want to base it off of a data type that you already have, like a list or a string. Sometimes you just want to do an operation X numbers of times and not necessarily based off an object. And so what you can do is use this command range, which will count through one number to the next. So this will proceed to have the for loop go through 6 times, and so you can have an operation that is just going through the for loop 6 times versus being based off of the number of fruits you have or something like that. You can have it be more legible on having 0 to 6 instead of going through the negatives, but it's whatever fits your use case. And so again, we can have this for be whatever variable that you want to name it, and then it's going through this operation, just this print operation 6 times. We can also use this variable to, for example, go through like our list indices. So for example, we can call back our fruits list, and we can iterate through the fruits list by using this x, but instead we're using range. And so the important thing to note is that the numbers for range, the first one is inclusive and the second one is exclusive. So what that means is that this range, like this x, it actually is equal to 0 and then 1 and then 2. It excludes the 3, so it's going up to 3 but not including. So one thing to note about lists is that if you go beyond the length of the list, you'll get a index error. So you can see that we have our first 3 objects that are in our list, but since we're going to one after the actual length of our list, we'll get this index error and we'll say the index is out of range. So that means that you're going beyond the size of your list. Another type of loop that Python has is a while loop. So while loops are good for when you want to do an operation while a condition is true. And so it will only stop for when that condition no longer resolves to true. So a quick example of this is this while loop would run indefinitely if we didn't have this line for changing what I is equal to. So I is equal to 1 initially, and then with this we're adding 1 to whatever I is equal to. So we're just steadily increasing I by 1, and so this while loop concludes when this I is is no longer less than 6, and so we can see that it stops at 5. And so this is good for when you know you have a certain condition up to a certain point, and then it will exit once it reaches that point. And so for homework, we can you can try doing the condition and loops exercise on Rosalind, as well as a couple exercises from their string algorithm section. You can choose whichever ones you want. Some are beyond what we've already covered, but some are within the information that we've already covered. So it's good practice on dealing with string data types. So thanks, and see you in the next notebook.